All right, so the first thing we did is we just figured out how to see how many zeros you could have, turning points, and then we used the signs to decide if we were going to have positive or negative zeros, and then we can figure out what the zeros could be and then solve for the zeros because I gave you one. So this is a multi-point question here. You will have points for possible number of zeros. You will have points for positive and negative zeros, the list of the rationals, and the zeros that you get, all right? So this is a 5-point question here. All right, so the first one's very simple. The number of zeros. What do we look at to find the number of zeros? Yeah, my degree. My degree. So that is going to be 3. All right, 3. And then positive and negative zeros. So this is where we use our signs, our positive and negative signs. So we are going to take our original function here, and we are just going to count our changes in signs to do this one. So for positive, we leave it the way it is and just count. So 2 is positive, 15 is positive. That did not change. All right. 15 is positive, 34 is positive. That did not change. 34 is positive, 24 is positive. That did not change. We will have 0 positive real zeros. All right, so for negatives, you do exactly the same thing, except you are going to, if it will let me move this guy, you are going to change your signs based on what would happen if you plugged in a negative, all right? So we're going to take this same thing here, and we are going to redo it, assuming that we plug in a negative to that x. So for the first one, if I plug in a negative to an x cubed right here, it's going to turn this sign. Whatever it was, it's going to change it because an odd exponent is going to change the sign. So this would become negative 2x if I put a negative in for my x. And so then here, if I take a negative to the second power, it's going to be positive. So this will stay a positive 15. That will not change the sign. I put a negative into an exponent of 1. It is going to change my sign. This does not have an x at all, so my sign remains the same. So then I'm going to recount. So for my negatives, I'm going to go back to this one, and I am going to count again. Negative to positive, that is a 1. Positive to negative, that's another 1. Don't move around. Negative to positive, that's another 1. I don't know why it moves when it does that.
So would the negative zeros always equal up to the
So this guy's going to be 3. All right. It's like you're putting a negative x in here and cubing it.
On my phone.
Okay, so that's going to be negative x cubed times 2, which makes it negative. It changes the sign. An odd exponent is going to change the sign when you do this. An even exponent is going to keep the sign the same. So like this was odd, so we changed this to a negative. This was even, we kept this a positive. This is odd, we changed it to a negative. This doesn't have one, it stays. And so then we recounted. The next thing it asks for is the possible rational zeros. So I'm going to take my factors of 24 and I'm going to put it over my factors of 2. All right? So possible. This is going to be a whole long list of factors. So I go through all of them. The first factor, so if I look at my 2, my factors of 2 are 1 and 2. All right? 1 and 2. So I'm going to put all of my 24 factors, all of my factors of 24 over 1. And then I'm going to put all my factors of 24 over 2.
Why would you put it over 1 again?
Because 1 is always a factor of your number. 1 is always a factor of any number.
So that's for...
All right, so what are my factors of 24? Well, 1 is a factor of 24.
2.
Positive and negative. 2 is a factor of 24. 3 is a factor of 24. What about 4? 5 is not. 6. Yep. 7 is not. 8. 9 is not, 10 is not, 11 is not. Yes, and what you can really do is it's going to be 1 and 24, 2 and 12.
24 also be positive and negative, or would it just be 24?
Positive and negative, yep. So 2 and 12, 3, and what do you multiply 3 by is the 8. Like, so you can just work your way in, by the way, when you get to these. All right, so that's over 1. And then you're going to put these over 2, all right? So I still have another row of these. So I'm going to put 1 over 2 as well, which is positive or negative 1/2. Now, when I put 2 over 2, what do I get?
1.
I've already listed 1. I don't need 2. 3 over 2 will not reduce, so that's going to be positive or negative 3 over 2. All the other ones, 4 over 2, 4 over 2 is 2, I've already listed 2. 6 over 2 is 3, I've already listed 3. 8 over 2 is 4, I've already listed 4. 12 over 2 is 6, I've already listed 6. 24 over 2 is 12, I've already listed that, so I don't need to list them again. These are all my possible numbers. All right? It is. All right, so now that I have all of this, I am going to actually figure out what my zeros are. And I gave you a 0.
-2.
So I gave you the 0, -2. So I am going to use synthetic division here to then figure out what the rest of them are. So I'm going to do synthetic division. When I hand you the 2, you don't change the sign. It's only when I give you a group with division that you change the sign. So you're going to use -2 here. And then make sure that it goes 3, 2, 1, 0. So I'm going to say 2 is in front of x cubed, 15 is in front of x squared, 34 is in front of x, and then we have our constant of 24. And then we just do the process. Add down, multiply up, add down, multiply up, add down, multiply up. When you do this, if you do not get 0 as your remainder, you did something wrong, okay? Because I just told you that this is a 0. By definition, that means your remainder will be 0. So this is a good check that if you don't get a 0, you did something wrong. Do not continue. Figure out what you did wrong in your synthetic division. All right, so I know that this is one of my zeros. So you can go ahead and list him like zeros. I know that -2 is one because I just showed that it was and I was told. Now I can take this guy right here, 2x squared plus 11x plus 12. And you are solving for where that's equal to 0. All right? Look how many zeros possible there are. You do not want to just pick and choose. You want to factor or use quadratic formula here. I promise that's what you want to do. Because there are too many zeros to try to go through it and figure out which one works. All right? If you want to factor, you can do it a couple ways. You can do a cross, remember? 2 times 12 is 24. Factors of 24 that add up to 11. What are they? 8 and 3, right? So then just 2x squared, rewrite it. Rewrite this 11 as those two factors, 8x and 3x. And then keep that the same. You can factor by grouping here if you want to. I'm going to show you both ways. Take a 2x out, x plus 4. Take a 3 out, x plus 4. Your factors are going to be 2x plus 3 and x plus 4. Where is this guy 0? It's 0 at -3/2. Was that one of our options? Yes, it was right here. This guy is 0 at -4. Was that an option? Yes, it was right there. So when you do this, I expect to see this list, right? I expect to see it listed number of zeros, positive, negative, possible zeros, and actual zeros. So I'm looking for those 5 things when you do this particular problem. If you do not feel comfortable factoring, you can always use the quadratic formula. Always. So quadratic formula would be -b plus or minus the square root of b squared minus 4 times a times C all over 2 times A. And then you just do order of operations. 121 minus, what, 96 over 4. So you would get negative 11 plus that answer over 4, negative 11 minus that answer over 4. And you would get negative 3/2 and negative 4 there. Is going to be online as well as the... I want to point out the fact that instead of points of discontinuity on your quiz, it's going to say vertical asymptotes here. So basically on your answer key, if it is listed as a discontinuity and not a hole, it is a vertical asymptote for the ones that I gave you, okay? So you can still use your answer key, just make sure that it is, if it is listed, like on this particular one, I think it lists 4 and negative 4 as discontinuities. However, 4 is a hole. So we're just gonna list negative 4 as a vertical asymptote. I'm not gonna say discontinuities, I'm gonna actually say vertical asymptotes here. So this one is also gonna be worth multiple points. You're gonna have points for the vertical, for the hole, for the intercepts, for the horizontal, and for the graph. All right. And I actually think I count the intercepts individually. So X-intercept, Y-intercept. All right. So let's look at this first. I will say that the Y-intercept is the easiest one to start with. So I always start with the Y-intercept because all I have to do, I don't have to change my function at all. I don't need to factor it. I'm just going to plug a 0 in for all of my X's. So I'm going to say 0 squared minus 7 times 0 plus 12 over 4 times 0 squared minus 64. You end up with 12 over negative 64, which reduces by 4 to 3 over 16. So your Y-intercept is going to be negative 3 over 16. My graph is already there, sorry. I guess I should show you how to graph. All right, the next thing I would do is my horizontal asymptotes, all right? So you can go ahead and, if you want to go ahead and do this on the y-axis, negative 3 over 16, he's going to be like, you know, right here, okay? So then I would move on to horizontal asymptotes because this is my shortcut. I'm going to look at the degree of the top and the degree of the bottom. If they are the same, I'm going to use the coefficient of this x squared and put it over the coefficient of this x squared. So my horizontal asymptote is going to be a line y equals 1 over 4 because they were the same. These are your shortcuts. Remember, if your numerator is bigger, you don't have one. If your denominator is bigger, it's 0. If they are the same, use your coefficients. Okay, use your coefficients. So then I have this horizontal asymptote then at 1/4. And so I'm going to go to 1/4 on my graph, and I'm going to graph a horizontal asymptote. And so remember, it is a dashed line because it is not actually part of the graph. It just shows you where your graph moves towards. All right, where it moves towards. Then I'm going to move to the ones that I actually need to factor it for, all right? What do I need to actually factor it? So now I'm going to move to factoring this equation and then see if things cancel, if they don't. So factors of 12 that add up to 7. Yeah, so I'm going to say the factor of the numerator is going to be x minus 3, x minus 4. In the denominator, I can take out a 4, right? So I would get 4x squared minus 16. What is that x squared minus 16? Right, it's a special case. So I have a 4, and then an x plus 4, and an x minus 4. Here, I am going to start deciding my discontinuities, my vertical asymptote and my holes, okay? So now that I've done this, I'm going to look at the vertical asymptote and my holes. Vertical is where the denominator is 0, but it does not cancel. Hole is where the denominator is 0, and it does cancel, okay? So where is the denominator 0? Well, it's 0 at -4 and at +4, right? -4 will zero out the x plus 4. +4 will zero out the x minus 4. Okay? So what cancels? Well, the x minus 4 will cancel, yes? So that is going to be a whole. So we have a whole at x equals 4. That is the one that canceled. We then have a vertical asymptote at x equals -4. Now to figure out where that hole would be, like if I want to actually graph the hole, I actually need a y value, even though there's a hole there. And so I can take this 4 and I can plug it into what's left. X minus 3, so 4 minus 3, over 4 times 4 plus 4. 4 minus 3 is 1, 4 plus 4 is 8, times 4 is 32. So 1/32. So if I go to the point 4 and 1/32, it's going to be right here, and I actually have a hole there. It's a hole, all right? And then for my vertical asymptote, I'm going to come over here to -4, and I'm going to draw a dashed line, x equals. So I'm going to come over here to -4, and I'm going to draw this dashed line. That is my vertical asymptote. All right? The only other thing I am missing is my x-intercept. My x-intercept. So my x-intercept is where the numerator is 0, but nothing else has happened, okay? So by that I mean x-intercept, that is where my numerator is 0. Numerator is 0. However, it does not include anything that's canceled out from the numerator. We've already established that as a whole, okay? So my numerator is 0 at 3 and at 4, but I've already gotten rid of 4. I've already told you what happens at 4. A whole happens at 4. So the only x-intercept I have is at 3. So my x-intercept is 3. So I'm going to go to 3 and put my x-intercept right here. And now, the bottom right part of this graph is easy to see what's going to happen, right? Because I can easily see that this is going to be kind of a curve. It's got to approach this right here, gets to that hole and jumps over, right? And then it has to approach this blue line down here. So my graph is going to do that. Where it sometimes gets tricky is on the other part of it. You need to graph over here as well. All right, so you need to graph this part right here as well. I make the assumption here, and you can check your numbers by plugging something in. Keeps going this way. But I have a reason for believing it's going to be up here. The reason I believe it's going to be up here is if it were down here, I would have to cross the x-axis sometime because I'm approaching that red line, okay? I know I don't cross the x-axis because I do not have another x-intercept. I only have this one x-intercept. If I had an x-intercept over here, then I would say this is going to be on the bottom. But I don't, okay? So this graph is going to be up here on the top. You can double check it if you want by just picking -5 if you want to and plugging -5 into your equation, and you'll see it's going to be above that horizontal asymptote when you do. So it has to do that kind of curve at the top. Did today foiling, all right? So they give you your zeros, and you just say x minus what they gave you, and then you foil it, all right? So I picked one that had a multiplicity because I wanted you to see one like it. So I have a 4 with a multiplicity of 2. So to set up my binomial, I say x minus my 4. And for this one, I do it twice because it said multiplicity of 2. X minus 4, x minus 4. Okay? And then I also need to account for this 0, -1. So I say x minus a -1. What does that change to? Yeah, so I'm going to change that minus a negative to a +1. And so those are my binomials here. And then I literally just FOIL. That's all I do. To find the polynomial that has these zeros, I'm going to FOIL. So I'm going to say x times x, x squared, x times -4, -4 times x, -4 times -4. Simplify this guy first before you continue. X squared minus 8x plus 16. And then FOIL it with the other guy, x plus 1. And I do the other direction just because it's smaller. So I say x times x squared, x times -8x, x times 16. Then I put my 1 through, 1 in x squared, 1 in -8x, 1 in 16. All right. And then I'm just going to simplify. Combine your like terms. X cubed cannot simplify with anything. -8 and +1 are going to give me -7. +16 and -8 give me +8. And then 16 cannot combine with anything. So they gave me the zeros and I found my polynomial versus on the first page where I gave you the polynomial and I wanted the zeros. Okay, it's just the inverse of what we've already done. So it's a really quick way to check if you at least did your multiplication of your variables correctly. Any questions? That is your whole quiz? That is your whole quiz? I want to say it's like 12 points.
I know how to do the last one. It's such a great quiz.
But the first two things are like 10 out of 12 points on your quiz.
Can I have a shoe?
So you may want to go back and review those.
How much time do we have?
Like 7 minutes?
How long did you study math? I have a test next. So. You know what? Bro, I have a test. Then a quiz. Then a quiz.
Y'all have Worldly Wise and Bible quiz.
Before that, I have a physics quiz.
We got English. No, we got you, English, and something else. I know I got like you tomorrow.
I need to find out what's on at work today so I can see if I can come back.
Gotcha.
If I can.
How do you find out what time you work today?
I have to check my app.
Do you want to go ahead and do that? Okay. You're welcome.
I didn't start it yet, but there's something I looked at.
I literally have never brought the book home and looked at it. Because like,
I had a
text.
something, I don't remember.
3:30 to 8.
Uh-oh, that's going to be hard to come to math tutoring. The videos will be like what? Anytime you have a radical, it comes in pairs, okay? Comes in pairs. You're going to have a plus or minus of that radical or plus or minus of the imaginary, okay? So they only gave us square root of 5 and negative I, but we have to assume negative square root of 5 and positive I. You have to assume that they came in a pair, positive, negative pair, okay? So while they only gave me 2 zeros, there were actually 4 that I know exist because they always have to come in pair if they are a radical or an imaginary, okay? When I do a problem like this, I always pair up my groups. So I'm going to say, again, just like I did before, x minus square root of 5 for that guy right there. And then minus a negative, so I'm going to say x plus square root of 5, okay? Then I'm going to say x minus a negative I, well, that's x plus I, and x minus I. So I always group them like this when I FOIL, because anytime you have them pair up like this, it's a special case. It's an A plus B, A minus B, okay? Which means when you FOIL, your middle term is going to go away, and you just have to square the first guy and square the last guy. It's a special case, just like when we factored x squared minus 16 and said x plus 4, x minus 4, okay? It's going to be one of those cases. So when I FOIL these two here, because it's the same thing but a plus minus, all I have to do is square the first guy. Well, that's just x squared. Subtract. You always subtract when it's plus minus. And then what is square root of 5 squared?
5.
It's just 5. So this is going to be x squared minus 5.
So
Okay.
it's always going to be
All right, so the same thing really happens over here. This is also a plus minus. So I'm going to square my x, that's x squared, subtract, and square your I squared. What is I squared? -1. So when I simplify this guy, I have x squared minus -1. So this is going to become x squared plus 1, and I have x squared minus 5. Now I have a rather simple foiling, right? It's just a binomial and a binomial. So I'm just going to FOIL him. X squared and x squared. X squared and 1. -5 and x squared. -5 and 1. And then I'm going to simplify. X to the 4th doesn't simplify with anything. 1x squared, -5x squared is -4, x squared, and then the -5 also cannot simplify with anything.